between New York and Massachusetts for access to rich markets west of the Appalachian Mountains, New York got there first with the Erie Canal. So in 1851, Massachusetts decided to surpass its rival by building a railroad. There was just one problem. Blocking the best route west was rugged Hoosac Mountain, all 5 miles of it. The man who would take on Hoosac was Alva Crocker, owner of the Troy and Greenfield Railway. Crocker was no engineer, but he was an astute businessman. His slogan was "On to Hoosac, on to the West." To shave years off the construction schedule, 2 teams would work simultaneously from both sides of the mountain. To make sure they met in the center, engineers had to carefully plot the tunnel route. If the 2 sides failed to join up, everything would be lost. To survey a precise tunnel, engineers relied on 2 things. The first was a transit. It combined a telescope, which really helps you see a long way, with a protractor-like device for measuring angles, and down here, a compass. The second was a lot simpler. Basically, a brass weight at the end of a string, called a plumb bob. Now here's how they used them to make sure that 2 teams on either side of Hoosac Mountain would eventually meet in the middle. Once the entrances had been roughly marked, surveyors cleared a path over the mountain. Using their transits, they carefully measured a straight route from one portal to the other. They also created 2 back sites, fixed survey points on mountains that stood behind each entrance, and plotted a perfectly straight line over the mountain, which they transposed as a perfectly straight route through the mountain. Once they determined that the 2 entrances were on the exact same line, they aimed their transits at the center and kept sighting ahead as they excavated, placing markers at regular intervals to keep the tunnel on course. It took 2 years just to map the Hoosac's route. But the effort paid off when, decades later, the teams met precisely in the middle. But boring into the hard rock of Hoosac Mountain was an exhausting, dangerous job. The air was stifling, and one slip of a hammer could break a man's arm. Much of the work involved hand-drilling long holes in the rock face, filling the holes with gunpowder, and exploding the charge. If a blaster couldn't sprint, it wasn't long before he was maimed or dead. Very quickly, the Hoosac Tunnel fell way behind schedule. The problem was gunpowder. It was no match for the hard rock of Hoosac. Each blast produced only a few feet of shattered rock. Legislators began protesting that the tunnel was costing the state a fortune. The project was close to bankruptcy when an English chemist named George Mowbray came forward to save the day. Mowbray arrived in America with his own recipe for a new and potent explosive: nitroglycerin. Nitroglycerin was considered so unstable that it was banned in Europe. But Mowbray insisted his formula would be safer. The Hoosac tunnelers, desperate to speed things up, had nothing to lose by trying it. The nitroglycerin was so effective, Mowbray built a factory on the site. But even this safe nitroglycerin remained unpredictable, and dozens of men were killed when it went off unexpectedly. Luckily, fate intervened.
During one very bad winter storm, the fellow that was responsible for delivering nitroglycerin over the mountain to the second heading His cart was upset, and at the time he thought that he would be killed instantly, but he wasn't. He discovered that the nitroglycerin had been frozen during his trip, and that it was very hard to detonate the frozen nitroglycerin. It was discovered by accident, but after that, all of the nitro was delivered in a frozen state to make it safer.
With the adoption of nitroglycerin, the prospects for very rapid and effective breaking up of the rock became apparent, but the process of drilling the holes in which the nitroglycerin would be placed was still very slow.
It was slow because the work had to be done with hand drills. But when compressed air drills were used in the Hoosac for the first time, the men could dig 3 times as fast. And in the choking dust, the drills had a welcome side effect.
And one of the big advantages of the compressed air drilling was that as the air was vented out of the end of the drills, it actually provided some ventilation. Prior to that, there was really no good way to ventilate the tunnel.
By 1869, work in Hoosac was making steady progress, but its finances were still in shambles. State commissioners had foreclosed on their loan and were looking for someone to finish the tunnel quickly. They chose Walter Shanley, a Canadian civil engineer. Shanley was the 4th man to hold Hoosac's top job and its best manager. He reorganized the work so that every phase of tunneling was treated like a station on an assembly line. Systemizing the tunneling process would finally push the Hoosac to completion in 1872. After 21 years and 200 deaths, the saga was finally over. Still in use today, Hoosac was a landmark for hard rock tunneling. Over the span of its construction, excavation by hand gave way to high explosives and mechanized drilling. Soon, engineers were building even longer tunnels in a fraction of the time. But explosives and power drills were no help for building tunnels through the soft, watery ground at the